understood what is algorithm, flowchart, and high-level language. Let's start with simple examples on algorithm and flowchart. Let's understand how we should start giving the instructions, how we write instructions in our own words initially. Initially, I will take very simple examples to understand the concepts of programming. Let's start with the first one. I want the computer to find the sum of two numbers, that is 10 and 20. Now, how do I give these instructions to the computer? What all instructions I should give to the computer to do this particular task? Now, my algorithm is like this. The first step, we start as start itself. We want the machine to find the sum of two numbers. Which two numbers? 10 and 20. So I should give those numbers to the computer. So I will say provide two numbers, 10, 20. After giving the numbers, what should the machine do with the numbers? It has to add the numbers. I need to give that instruction. I will say add the given numbers. I have given the numbers. I have told what it should do with the numbers. Next, it will do the addition and it has to give me back the result. Now, unless I ask for the result, it will not give it back to me. So I need to give that instruction specifically. So I will say now print. You can say print, you can say display, choice is up to you. I will say print sum, end of my algorithm, terminate this with stop. Now, I have written these steps in my own words. You can also write it in your own words as long as it is meaningful to whoever reads your algorithm. Now, once I write this algorithm, I will go through this. If I feel, yes, I have given the overall steps required to perform the sum of two given numbers, then I can convert it into flowchart or any other programming language like C or Python and so on. Let's take a second example. Next one is, I want the computer to find the area of a triangle. So if the machine has to find the area of a triangle, what are the steps it should follow? So first step is going to be start. To find the area of a triangle, what data is required? So we give the base and the height of the triangle whose area has to be calculated. So I'm going to provide the base and height. Provide base and height. As, let me give some numbers, 9, 3. Give whatever data you want, whatever numbers you want. What should the computer do with these numbers? It should apply the formula and calculate. So I have to provide the formula also. Calculate area as half into the given base, whatever is given, into height. What should I take back from the computer? I should take back the result, which is area. So I will say print area or display area. End of my algorithm, terminate this with stop. So let's go through this once again. Have I given the required base and height? Yes. Have I given the appropriate formula? Yes. And am I doing the print? Yes. So this is the algorithm to find the area of a triangle. Next, I want to write an algorithm to calculate voltage. To calculate voltage. Now, pause the video for 2 minutes. Write the algorithm in your own words. Let's check. First step, start. To calculate the voltage, we know that we have to take current and resistance. So I will say provide current and resistance. You can say current and resistance, or you say I and R, up to you, whichever way you want you can give. Current and resistance as 5 and 2. Next, what should it do with this current and resistance? It has to calculate the voltage. How should it calculate? I need to tell the procedure. Calculate voltage as the given current into resistance. Print voltage. End is stop. So these are the steps to make the computer find the voltage. Let's take one more. To find area of a circle. First step, start. What should I give? I should provide the necessary radius. Provide the radius. You decide what value you want to take for radius. I will take it as 5. Give the formula to calculate the area as pi into radius square. You want radius square or you want radius into radius? Use any of those methods. Doesn't matter. Print area. End of my algorithm is stop. So now we have seen 4 basic algorithms. Now notice that in all these algorithms, we are supplying some data, we are giving the process, and we are taking back the result, which is the output. Let's take the next one. Here also, we are providing data 9 and 3. We are applying the formula process, area calculation, and we are taking the output print area. Similarly, in voltage, we are giving the data 5, 2. We are applying the formula current into resistance, and the output is voltage. And similarly with the area of a circle. So now, the next task is we will convert these algorithms into flowchart. Now, when we are converting this into flowchart, flowchart is also for us. We write it in our own words. But what we do is we start following the rules of our language to a certain extent. It's not going to be as generic as your algorithm. So now, let's start with the first algorithm conversion to find the sum of two numbers 10 and 20. How do we represent that in the flowchart? So my flowchart is going to be, again, we start with the first step as start in a rounded rectangle. Put an arrow telling that you're going in this direction. What is the second step we have given in the algorithm? We provided two numbers 10 and 20. Now, let's understand whatever data you give to a computer, where does it go, how does it get stored, how do we refer it? Now, when I give the numbers 10 and 20, we know that every piece of data that you give always goes into RAM. Now, RAM, let's take the RAM over here. This is the RAM diagram what I have. It has got many bytes. So, each cell what I have drawn over here is a byte. Let's assume that 10 goes into this particular byte and 20 goes into this byte. Which byte is not under my control? That is decided by the system. Wherever the space is available, it's going to store that particular data. And also remember, 10 and 20 is not the only piece of data that will be stored in the RAM. There might be a lot of other data and instructions in the RAM. Okay, I have now given 10 and 20. What is the third step we gave in the algorithm? We gave add the given numbers. Now, who is going to do the addition? This is done by your CPU, and to be more specific, it is done by ALU, that is Arithmetic and Logic Unit. Now, ALU is responsible for doing the addition, subtraction, multiplication, basically all calculations. Now, I need to tell my ALU, take the given numbers and do the addition. But there is a small concept which you have to keep in mind. Where is the data stored in RAM? It can be anywhere in RAM. Like as I said, it is not under our control. So, how do I tell the ALU where the data is that it has to pick up and do the calculation? So, we have to solve that particular problem. That means we need to identify the data stored in RAM. And that identification is done by giving some name. That means I will not just provide 10 and 20. I'm going to say A equals 10 and B equals 20. What does it mean? It means that wherever 10 and 20 are stored in RAM, they are identified as A and B. So, this is now called as A and this is called as B. Now, how will I give my instruction to the computer to do the addition now? So, here in the next box, in a rectangle, again, put an arrow. Now, in a rectangle, specify the calculation as A plus B. So, now ALU knows which data should be picked up or what data should be provided to the ALU. It will do the addition 10 and 20 and give the result back to RAM. So, now A plus B is 10 plus 20, 30. 30 is stored in some location. So, I need to name this particular location. How do I do it? When I give this formula A plus B, I will say C equals to A plus B. So, that means do the right hand side calculation. That result you call it as C. So now this is named as C. Next part, I want to print this result. So put a parallelogram and here we will say print C. End of my flowchart, terminate this with stop. Right? Now, so what we do over here is every piece of data that you give or every piece of data that is calculated has to be done with identifiers. So how many identifiers I'm using in this example? I'm using 3 identifiers. What are they? A, B and C. So what are identifiers? They are used to identify the data stored in RAM. Now, we understood what an identifier is. Let's go a little more deep into these identifiers. An identifier can also be referred as a variable. An identifier can also be referred as a variable or it can be referred as a constant. What is the meaning of this? It means how we want to treat that identifier. If I want to treat the identifier as a variable, it means that whatever value is given for that identifier, it may change in the program if you wish to. But if you want to treat that identifier as a constant, it means that whatever value we have given initially, it cannot change. Even if you try to change, it will not allow you to do so. So based on the requirement, you have to decide whether your identifier should be treated as a variable or it should be treated as a constant. Now coming back to this example, what I mean over here, A, B, C, by default, they are treated as variables. If I want to use it as a constant, then how do I do it? So instead of saying A equals to 10, I will say constant A equals to 10. Or you can also write const A is equal to 10. Up to you, whichever method you want, you can specify that in the flowchart. So this is about a variable and a constant. Now, what are the names that we can give for the variable or a constant? In this example again, the name I have taken is A, B and C. It need not be made up of a single alphabet. It can be made up of words. It can be made up of words, digits and the special character underscore. Let's see some valid names. A equals 10 is valid. Equal to is also called as assign. I'm assigning 10 to A. I can also say num is equal to 10. What is the meaning of this? In RAM, 10 is stored and I'm naming it as num is valid. I can also say num1 is equal to 10. The name is made up of alphabets and digits. I can put an underscore num underscore 1 equals to 10 is valid. But I cannot begin the name with a digit. So look at this. I cannot say 1 num is equal to 10. This is not valid. I also cannot use any other character, special character apart from underscore. I cannot say num space 1 is equal to 10 is invalid. Nor can I say something like num hash 1 is equal to 10. Nothing is allowed except underscore. This is how we specify the names. There are also some more rules you need to keep in mind when you assign the values or when you give formulas. What are they? Let's look at it again. A equals to 10. We know what is the meaning of this. 10 is stored in RAM and it is called as A, or we say 10 is assigned to A. I cannot say 10 is equal to A. This is invalid. What is the meaning of this? The right hand side is always the source and the left hand side is where you're sending it to, who is receiving it. So A equals to 10 is valid, but you cannot assign A to 10, which is invalid. Similarly, when I say C is equal to A plus B, what is the meaning of this? A plus B is calculated and it is assigned to C is a valid statement. But I cannot say A plus B is equal to C. This is invalid. So always be clear with what is on the right hand side and what is on the left hand side. Now, this is about the rules of variables. And also another point, to a variable or a constant, you can give initially only one value at a time. What do I mean by this? I cannot say A is equal to 10, 20. Don't try to assign multiple values to a variable or a constant. They can take only one value at a time. Let's take the second example. The second example of the algorithm was to find the area of a triangle. Now let's see how to convert this into a flowchart. The first step is start. I had given the data as base as 9 and height as 3. So I need to give this in terms of variables inside a rectangle shape. What name I should give for the variables? You can say b is equal to 9, h is equal to 3. But instead of taking single alphabet, let's take a word which is meaningful. So I will say base equals 9, height equals 3. What happens in RAM? It's important to visualize. So let's draw the blocks here. So I have 9 over here and 3 here. This is called as base and this is known as height. What is the next step after providing the data? I need to apply the formula to do the calculation. That is the process. So this is half into base into height. Now I need to be careful with the spelling. What is the spelling I have used? BASE. So I have to use BASE only because that is a name that is identified in the RAM. Into this is height. What is this entire result called as? I should give a name for that. So I'm going to call this as area. Now because of this, area will be calculated by the ALU and it will say 9 into 3 divided by 2. I will get the result as 13.5 and in the memory this is now called as area. I need to print this on the screen. So within a parallelogram, I will say print area. And end of my flowchart, terminate this with stop. How many variables I have taken in this flowchart? 3. Base, height, area. Okay, now pause the video for a minute and you write the flowchart to find the voltage. Refer to the algorithm of the voltage, write it. Alright, let's see the flowchart for this. For the voltage part. Start. Supply the data in terms of variables. You can use the word current, resistance, or you can use the variable names as I, R, up to you, whichever name you want. I will use I and R. I equals to 5. R equals to 3. So what is happening in the RAM now? So I have capital I called as 5. R is called as 3. What is the formula to calculate the voltage? V is equal to, now since I have used IR, I should stick to that same spelling. I into R. Don't say current into resistance. Be careful with what name you have used, stick to that. Now because of this step, what happens inside the memory? V is created with the value 5 into 3 as 15. Now I need to bring this on the screen, print it. So within a parallelogram, print V. End of my flowchart, terminate this with stop. How many variables in this case? Also 3 variables, I, R and V. Let's take the next one. Finding the area of a circle. Let's do the conversion for this also. Start. What data we provided? Radius, I will call it as R, equal to 5. So let's put the memory blocks. R, which is 5. Then what is the formula? Area is equal to pi value, you need to specify that. So 3.142 into R square. You say R square or you say R into R, your choice. And print this. Print area. And stop. So this is area, which is going to be 78.5 something. So this is the flowchart for finding the area of a circle. So What did we understand now in these 4 examples? We understood how to write flowcharts. We understood what symbol should be taken, which block should be taken, and we understood the concept of variables and constants. So everything in programming, all data is in terms of variables or constants. So you have to be comfortable with this particular concept.